All right. Hello, everyone. Welcome to our first video tutorial. Long time no speak. What we're going to do is go through some of the changes that you might have seen on Blackboard, syllabus, go through the lecture notes, show you a couple of examples, and then talk about what's going to be due this week. So you can see if you go onto Blackboard, under course information, you'll find the updated syllabus as well as the lab update. This is going to go into detail about how we're going to complete the last two labs. The syllabus will look like this. So it has revision notes talking about how everything's adjusted. Then if we go down, I've basically highlighted and crossed out all the old information so you're aware of what it used to be. So we do not have any lectures in class. We're just going to have the lecture notes in these videos. Labs, see that lab update file. As far as the grading, I posted a note on that in the previous announcement, but you'll see we're going from 10% for assignments to 20 because we're doing 2 more of them. The labs, since we're doing 2 less, they're going from 30 to 25. The final exams going from 30 to 15 will be done online. And we're adding 3 online quizzes, which we'll get to. Now, you'll see that those changes are kind of reflected in the rest of the syllabus, but then you'll notice the timeline. Basically, we missed this week. That was this past week. This is the current week. So Valve lecture notes and then listen to this tutorial, which you're doing right now. Good job. Normally we'd be doing the 6th of the rotational labs. Instead, there's going to be the online quiz and the assignment. Next week we'll deal with encoders, online quiz and assignment for that. 3rd week from now we'll do end of arm tools, online quiz and assignment for that. And then the final week we'll do the online exam. So, as I mentioned as well, don't forget to check out the lab update. This will kind of break down who's going to be doing what, because as you know, some of you have done all the KUKA labs, other ones haven't done the KUKA labs, and so forth. So this will go through and explain that for your particular class. So if you go back to Blackboard, you'll see under weekly learning, lecture notes will be posted, so control valves. This video will be in here as well. Obviously you found it since you're listening to it. Assignments, you'll go to assignment 2, valves. This is already posted. There's the questions. There's the link that you're going to need, which we'll go to and take a look at this assignment. So for this assignment, you're going to have to draw a couple of symbols based on the information above. Then we have this catalog link. That's the link I mentioned previously. So if you click on this link, it's going to open up this location. So this is the SMC, which is a valve manufacturer or all kinds of pneumatics. And then what you're going to do is in the question, it says, okay, list the serial number that meets this criteria. So 2-position double acting. If I go into this, you'll see here's the serial number. And you'll see how this will change the serial number up here. And then go through, change these values based on what that table says, and then give me what the serial number is. Then you're going to do that in reverse. So here's the serial number. Go through, make the changes to figure out what that serial number is trying to tell you, and then give me that information. So list it here. So is it base mounted, what kind of locking system, etc. Then here, these two questions, this will be related to the end of the lecture notes as far as problem solving and troubleshooting for problems. So short answer, multiple choice. And then with this question, you're just filling in what the action is. Is it single or double? How many ports? How many positions? If it has a center, what type is it? If it doesn't have a center, then leave it blank. And then this, we're going to draw two schematics. So one schematic is going to show the cylinder extended. The other is going to be in the retracted state. So there'll be two schematics of this same system. So you'll see a couple of examples of this in the lecture notes as well. The Blackboard, that's where your assignments were. Okay. So this will be due on Saturday at 5 p.m. You could type out most of your answers in here. You can draw some of them on paper, for example, with this. Take a picture, put it in here, insert it, and send me the whole file, or send me the picture separately, or you could give all your answers on lined paper, take a picture of that, send it in multiple different ways. If you have any issues, just let me know though. Then we also have this quiz. So this will just be 10 multiple choice questions. Should be relatively straightforward. This is going to be due Saturday at 5 p.m. as well. You'll get 2 chances to do it, and the best mark will be kept. That's it. Now let's get into so getting into the lecture notes. We already dealt with some of this stuff in our last class. So the manifolds themselves, the different types, how they work, seeing the manual overrides and where the ports are and so forth. We talked about the symbols a little bit. So here you can see each one of these boxes represents a different position that the valve can switch to. So 2 boxes, 2 positions. And then inside each of the boxes, there's going to be arrows pointing up, meaning pressure is going towards the cylinder, or it'd be pointing down, meaning it's being exhausted. And you can see where the ports have exhaust, triangle pointing down, or have air pressure, triangle pointing upwards. The other option, instead of arrows, you might have ports being blocked off, meaning the port is not being used in this position. Then we got into multiple different types and then vernacular. So in this case, if we look, we have 2 boxes. There's 1, 2, 3 ports, known as a 3 two-way valve. And if we looked over here, for example, this has 1, 2, 3, 4, 5 ports, 2 positions. It's a 5 two-way valve. Even if the port's not being used in this position, you still count it, because in this position it is being used. Now, you should also keep in mind, as we discussed, I can tell if this is using a single or double acting cylinder, it must be controlling a single acting cylinder because there's only one air line going to the cylinder. So the top is what goes to the cylinder. Whereas this one, this must be controlling a double acting cylinder because there's 2 air lines going to the cylinder. Then that's just going to show what the valve symbols look like. as far as the positions, what controls the valve will be these symbols. So you could have manual overrides. Those were those little things that we pointed out before. So you press that, that'll cause the valve to shift automatically. This one has these little gray ones down here. They can also have springs to cause the valve to shift. And then here's the solenoid symbol. So this is the electrical contact that's going to cause the valve to shift. So you'll then go through the rest of the examples showing you the symbol, but then also showing it being applied. So here is a double acting cylinder, has 2 air lines going to it, so it must be double acting. This has 1, 2, 3, 4, 5 ports, 2 positions, so this is a 5 two-way valve. And the action for the valve itself, it has a spring on one side, which pushes this position in place, the solenoid on the other side. So this is a single acting valve. We only control one action, the spring controls the other one. So if we turned this solenoid on, that's going to put this position in place. And this causes the air pressure, instead of going up to the right to retract it, the air pressure goes to the left to extend it. If we turn this off, the spring would push it back into place. So you can have double acting cylinders, single acting cylinders, single acting valves, and eventually, there we go, double acting valves. So there's a whole big combination of them. So read through that part. This kind of shows a little bit better 3D model showing what's actually happening inside the valve itself. So this is the valve that's shifting back and forth. So air pressure is coming up here, going to the left air line. The right air line is going to exhaust out. Then when this is shifted over, the air goes to the right and the left is exhausted out. So on the left here, this is the solenoid. That's causing this to push over. When this is not activated, this is retracted the other side by the spring. So there's a couple different examples showing this. Here's 2 solenoids. So this one's activating, pushing it this way. Air goes to the left, exhausted out the right. Now this one's activated, pushing it the other way. Air goes to the right, exhausted out to the left. So some more examples being shown. This gets to talking about if we have 3 positions. So you should be able to answer all these questions when it comes to the symbols. And one of the options is if it has a 3rd position, that means it has a center. The center options that you'll see are pressurized, vented, and locked. Pressurized means that this is going to supply air pressure. The cylinder will stay wherever its current position is. Active pressure on it. Whereas if this is the center, this means that the air is being vented out. So the pressure would be coming here, being blocked off, and the 2 air lines from the cylinder will be exhausted out to the atmosphere. So this will be able to float freely. And then there's locked. Everything is locked in place. Wherever the cylinder is going to stay, wherever the cylinder is, it will stay. It just won't have active pressure pushing on it. So these positions are going to come into play when we lose power to the valve. But they can only be used for a double acting valve, which I'll show you why in a minute. So you'll see here's an example. If we look, we have 1, 2, 3, 4, 5 ports, 3 positions. So it's a 5 three-way valve. The center is exhausting out. It's being vented down and out to the atmosphere. So arrows pointing down, that's exhausting out to the atmosphere. Arrows pointing up, pressurized, locked. So what's happening with this is, if you activate this solenoid, this position is going to be moved in place. If you turn it off, you'll see there's two springs pushing this into the center. So if that happens, then the air that's in the cylinder will just exhaust out to the atmosphere. If you activate this solenoid, this will slide into place and the air is going to go to the left port. So we'll show you a video showing the animation of basically how this will work in a minute. So you should be able to go through these questions and answer them. This will help for the quiz because it's going to be asking questions similar. And here, as I mentioned, for the assignment, where you're going to have to draw the two schematics of the same system, one retracted, the other extended, use these two examples as a basis. So single acting cylinder controlled by a single acting valve in its retracted state. The same system, there's a single acting cylinder, single acting valve, but it's in its retracted state. So you can see the air pressure is blocked off. The air in here is exhausting out to the atmosphere in the right position. The left position, air goes, extends it, the exhaust is blocked off. So we only ever draw this in one position at a time. So we wouldn't combine them all, so you only have one position shown ever at one time. And then this is similar scenario, except now it's a double acting cylinder controlled by a double acting valve. And you can see this would have to have manual overrides on both sides. Then at the end of the lecture note, you'll see it talks about any kind of problems that you might run into. So there might be air-related, electrical, or mechanical. It breaks down basically how to troubleshoot these things. So make sure you understand those, because that will be a part of the assignment question as well. Now, if we go, so in this video, you can see we have air supply coming here, and the position of the valve inside is directing it to the right. The left side is going to be exhausting out. Then when this shifts over, same pressure is now going to the left. The right is exhausting out. Here we have an animation to show some comparisons of working systems. So on the left, we have a single acting cylinder. I can tell it's single acting because it has a spring and only one airline. Then the valve itself is also single acting because it has a spring and only one solenoid. This is a 3-2-way valve. There's 3 ports, 2 positions. Compare this to this schematic on this side. This is a double acting cylinder because there's no spring in the cylinder. There's 2 airlines coming from it. The valve, though, is single acting because it has a spring and only one solenoid. So just because the cylinder is double acting doesn't mean the cylinder has to be double acting. As far as the number of ports and positions, this has 1, 2, 3 ports. Sorry, 1, 2, 3, 4 ports, 2 positions. This is a 4-2-way, and this also has a manual override on it. So I have electrical schematic down here with a push button hooked up to both of these solenoids. So if I press this, you'll see this solenoid was activated, shifts the valve, air pressure, extends it. Same thing happened here. This position goes into place, air pressure extends it. If you let go of that push button, solenoid is no longer activated, the spring will push the right position back in place. So with single acting control valves, if the solenoid's not on, the spring will push the valve back into place, which will cause this to move. So single acting control is not as common as double acting control because we have less control over it. If for some reason we lost power, the cylinder is going to retract. We don't want that in a lot of cases. Now to compare this down here to double acting control, so we have a single acting cylinder, double acting cylinder, but now they're controlled by double acting valves, so no springs. You can see in this example, these have manual overrides on both sides. This one doesn't. Most come with manual overrides though. So if I look at this, the difference that's going to happen in the control is if I press the push button and let go, I activate this solenoid and this solenoid. They're going to stay extended because it will only shift back to the right position when the second solenoid is activated because there's no spring. So if I press this other push button to activate the second solenoid, this solenoid causes this to shift into place, and now it retracts. So press the button. So this is very common because this will never retract accidentally. If we lose power to the solenoid, it doesn't matter. It will only move when the solenoid is actually activated. So you can see, just because it's a single acting cylinder doesn't mean it needs to have a single acting valve. To finish up, going to our 3 position, you can see this is 5 ports, 3 positions. The center is locked. You'll see this is the way the schematic is commonly drawn, but it's actually not showing the springs to center it. So if you look, this is almost the same schematic, except this has spring centering it. So this is double acting cylinder, double acting 5-3-way valve. So 5 ports, 3 positions, spring centered. Now with a 3-position valve, it has to be double acting because the only way to get 3 different positions, this solenoid turns on, 1 position, pushes this in place. This solenoid turns on, the 2nd position. Neither one is on, the spring center it for the 3rd position. You can't do that with a single acting control. Turn this on, 1 position. Turn it off, a 2nd position because of the spring. That's it. So you know if it's a 3-position valve, it has to be double acting. So if we look at this particular thing, the top one, which I mentioned was missing the springs, if you press this, you'll see the left position goes in place. Solenoid's not activated anymore. This should actually have slid or switched back to the center position like this one did. Activate this. So even though it's very common, to see these drawn without the springs, just be aware that they're always going to be there. They just might not be shown because they're just assumed that they're there. But technically they need to have springs because I'm holding this push button down to activate this solenoid, and as soon as it's let go, it shifts this back into the center, which is locked, which just keeps it in its current state. Activate the other solenoid, shifts back to center, stays locked in that position. So through all of that, lecture notes, quizzes, assignments, I did mention in the announcement that there'll be an open meeting for any of you to join. So I'll be posting the meeting invite on Blackboard tomorrow. If you want to email me as well with questions, that's perfectly great. Otherwise, I hope everyone's doing well. If you have questions, feel free to email me, or I'll see you at the virtual meeting on Tuesday.